You're watching the free version of SynthEyes Essentials. For projects and footage, head to BorisFX.com for the premium download. Hey, and welcome back to part 2 on exporting from SynthEyes. In the last class, we figured what we actually wanted to export. In this class, we will get into how to actually get this data out of SynthEyes. To do that, we will resort to SynthEyes' extensive exporter list. As you can imagine, both you and I don't have the time and the stamina to go through all of these exporters. What we will do instead is this. We will go through exporting the reference movie, the software-agnostic data, and the undistorted image sequence. After that, we will do a round-tripping example using Blender and Blackmagic Fusion, showcasing the workflow and the potential bottlenecks. As an example, I will use the shot from class number 10, the chessboard. It has got a proper visible lens distortion and a defined real-world scale we can easily verify in both Blender and Fusion. I just changed a couple of things in the scene that you should be aware of. I resolved the shot using the standard radial fourth-order lens model. I also adjusted the ground plane to be on the table instead of the board itself. I added another box as a reference for the whole chessboard, and I moved the cube a little bit. So without much further ado, let's get into it. The reference movie. I already teased this when we talked about navigating the perspective view. Up here in the mouse toolbar, we have a little render button, and we can use that to export a play blast or preview movie. This is really just meant for you to export a quick state of your work in progress. I will get into why you want to use another option to export the reference movie in a bit. But if that work in progress play blast is what you're after, then you are exactly in the right spot. There are two ways you can access this function. Either click the render button or right-click and choose Preview Movie. You can choose to just export the grid and the geo. In our case, that would be the cube and the board. Or you can export everything in the viewer. This is literally what you see is what you get. So whether you have solid meshes on, the horizon line, whatever, it will show up in that play blast. But what is really neat, you can also export a movie when you're not locked to the camera. So that allows for some nice behind-the-scenes angles. But there are two caveats to this. This is only available in the perspective view. No previews from neither the camera nor the orthographic views. That's caveat number 1. Number 2 is a bit more problematic. The play blast doesn't give us the option for lens distortion. Specifically, it will give us an undistorted background image that is cropped to the resolution of the source file. So that's not ideal. Let me show you how we would export a reference movie with the distortion reapplied. Just for illustration purposes, let's go to the lens room first. But you can do this from anywhere inside of SynthEyes. Go to the huge exporter list under File, Export, and find the Save to Sequence submenu. Now that will give you exporters for various formats. Pick the one that you prefer. Here you can choose what kind of timecode or frame number burn-in you would like to have, and if the meshes of your geometry should be solid or outlines. Note that the trackers will not be included in this export. And then we do see an old friend, a lens workflow. Yes, we need to figure out those very workflow-specific names again. But this might be easier than you think. For all our other exports in this example, we are going to be using the Redistorted 2 workflow because we want to deliver a redistorted image at the end. But if we choose Redistorted 2 here, we will get an undistorted, overscan version of our image. That's not the kind of reference movie we are after. No, we do want exactly what we are seeing in the lens room now, so we are going to choose None as a lens workflow. This little wipe should illustrate this a bit better. This is our Playblast export, and this is our export via the Save Sequence exporter. With that, we have our reference movie properly exported. Next up is the Undistorted Image Sequence. This should be easy business. Basically, we are going to use the same exporter. I will go with the file sequence, as that is much more suitable for us using it as a backdrop in a CG application. Note that by default this will be 8-bit, so if you plan to use this for texture extraction, etc., I would recommend we change one little detail. Go to Shot and select Edit Shot, and there we can change the process bit depth to something a little bit less lossy. Once you confirm, your image sequence will recache. Of course, you can also do this from the start when setting up a shot, but it will slow SynthEyes down a bit. And this time, of course, we have to choose the Redistorted 2 workflow. Keep an eye out for my tracker radar while we do the export. Did you see that? For a moment, my tracker radar went absolutely berserk. This is nothing to worry about, but SynthEyes is temporarily applying the undistortion to the entire image for export, but only for the export. That is why it quickly changes back again, and you can also see some recaching in your time bar. But this way, it is much easier to apply a certain lens workflow without having to keep track of it in the lens room. ST maps. Now our software-agnostic data package will consist of 2 elements. As we are already deep into lens distortion, let's start with the ST maps. ST maps are basically images that contain a UV map which conveys the distortion data. Let's go to the lens room and run the lens workflow for Redistorted 2. Now, in the menu bar under Shot, select Write Distortion Maps. I would suggest you use OpenEXR as a format. Did you notice it said Write Distortion Maps? Yes, because we will actually get 2 files, one for the undistortion, one for the redistortion. Let me quickly show you that in Fusion. This is the original clip of our chessboard, and this is the ST map. Now notice that of course this one is larger, as it accounts for the overscan. If we call up our undistorted image sequence from our previous export, we see that the dimensions are exactly the same. Nice! In Fusion, we use a texture node to apply the distortion. So I will plug this in, and if we now compare the undistorted version that we generated inside of Fusion with the ST map and the one that SynthEyes exported, those look exactly the same. Now let's take a look at the second ST map. That has got the original dimensions of the footage, 4096 × 2160. And this works exactly the same way. We apply that map to our undistorted overscan image and then redistort it. Apart from some minor filtering, our original image and the redistorted image should look exactly the same. So now back to SynthEyes. And please, the first thing we do is run the undo earlier run script. This is a little gotcha of writing out the ST maps, as it doesn't support the lens workflow on export, so be aware. Alembic. As far as our software-agnostic exports go, this is the central element. The Alembic will contain the camera movement and the geometry. The exporter will ask you for the location and name to save the file. Once you've specified that, we will get a lot of options to customize this. As the software-agnostic export is more of a fallback, we will leave most of these at the defaults, but it is worth walking through some of those options, just in case you'll need to adapt them. Timeline setup is pretty much self-explanatory. You can opt to only export a part of the range, but in most cases, you will want to export the entire scene. The starting frame is something that you might want to change. In a lot of facilities, the default starting frame is 1001, a precaution for those ever-feared edit changes. Export which shots is more of an advanced setting and applicable if you've got more than one camera in your scene. Output axis setting. So we talked a lot about Z-up and Y-up in class number 10. The most important thing first, it doesn't matter which way you have your SynthEyes configured, the conversion is made by SynthEyes automatically under the hood. But if you load up the Alembic in another software and it shows up tilted, this is where you want to change it. Image orientation. Once again, more of an advanced setting. This is interesting if you want to texture the geometry you created in SynthEyes in the app you export to. Don't get distracted by the software names and brackets, those are just examples. In most cases, you want to leave that at default, but if your texture turns out to be flipped, there's this setting for you. Include normals should be checked, as the normals of our geometry should come in really handy if we want to texture them downstream. Additional scene scaling. We will look at this in more detail when we come to our Blender export, but as the Alembic is our fallback, and we don't know where this fallback alembic might potentially be used, let's leave this on its default 1 for now. Fixed anamorphic distance is once again an advanced setting. We didn't cover anamorphic lenses in this course, so we will leave this at its default. Use quartz. If your software has problems displaying the geometry you export from SynthEyes, then unchecking this will force the geometry to be only using triangles, like on the mesh we created in class number 11. Create tracker chisels. Now this is an important one, and I would keep this on. These can be really helpful to check the correct alignment of the alembic in the host application. They are also quite handy for checking the accuracy of your track. The chisels also have a size override if they turn out to be too small or too large. Create screen. Should your alembic contain a screen that you can texture with the undistorted image sequence you exported? Absolutely. All the settings down here allow you to configure that screen even further, but like with so many of the options above, you will only need to touch these if your initial alembic doesn't do what it is supposed to do. Last but not least, we need to pick the correct lens distortion workflow. Once again, we opt for redistorted 2. Software-specific data. Now this is the fun bit, because with these, SynthEyes will take over a lot of the grunt work for us. Let's start with Blender. The first step is once again to specify the output file. Once done, we get our custom export dialog. We already know the timeline setup from the Alembic export, as we do the starting frame bit. Blender version. Now especially with a software like Blender, this kind of setting is important, as Blender has a tendency for drastic changes between versions. So make sure this one is correct. The hex mesh workaround refers to older Blender versions. Then we can specify if we want SynthEyes to create a new scene for us or just dump everything into an existing open Blender file. Yes, we are going to leave this one on Create New Scene. Create Armatures is once again a Blender-specific setting, and unless you run into issues with your vertex normals, this should stay checked on. Update Mesh Caches is only relevant if we have animated geometry or animated lens distortion inside of SynthEyes, both topics that we didn't cover in this Essentials course, and they are only important if we want to update an existing Blender scene. So let's keep this unchecked. Use quartz and fixed anamorphic distance are the same as with the Alembic export. Rescale Scene does exactly what it says on the box, and we will get back to this one in a moment, but for now, let's leave it at its default 1. Tracker size is more of a display preference than anything else. This whole section here are once again detailed settings on how Blender will set up the camera screen, meaning the display of our footage inside Blender's 3D environment. The defaults do a pretty good job, and if you need to get into the nitty-gritty of these, a good starting point are the tooltips displayed if you rest your mouse cursor over any of these options. Delete pre-existing meshes. If you are a Blender artist already, you know that each default Blender scene shows up with a cube in the middle of its scene. Normally, we don't want that in there, and this will delete that pre-existing cube. But if you have a custom Blender startup file and want to keep everything from there, then uncheck this. This section here is also quite nice. If you specify Blender's location on your system, then SynthEyes can launch Blender immediately on export. The prefixes are only really applicable if you want SynthEyes to launch that script, for example, on another machine. So unless you are a TD in a VFX pipeline, you probably don't want to touch these. And once again, we have to configure our lens workflow. So let's run this and SynthEyes will do its magic. It launches Blender and isn't this beautiful? Everything is lined up for us. We've got a projection screen with the overscan, our trackers and geo are all there. Even the file output settings are all correctly set up. Let's bring in some elements into our scene. As I'm not much of a modeler, I will be using a third-party asset from Kitbash 3D. So let's put a nice tasty apple on that table. I pick that out in the asset software and import it into Blender, but where is it? It shows up in my collection over here, but I can't see it. I have to scale it up insanely to make it visible. But we did get through the whole trouble of setting up the distance constraint in SynthEyes, so why is this happening to us now? Remember that SynthEyes is metric agnostic and that we told SynthEyes that each square is 4 units wide. The fact that 1 unit equals 1 centimeter so far only exists in our minds. So let's use Blender's measurement ruler and measure out this cube. 4 meters. Now that's one giant chessboard. Let's go back to SynthEyes and fix that. I will call up the Blender exporter again and just change the rescale scene factor to 0.01. If my algebra is not completely messed up, that should turn 4 meters into 4 centimeters. Inside of Blender, let's pick up our measurement ruler again, and that looks much more reasonable. But where did our projection screen go? The film back of our Blender camera is clipping that off. I will quickly increase the far plane of the camera here in Blender, and there we go. And to show you why fixing the scale right now is so important, let's bring that apple in once more. Now that looks like a realistically sized apple from the start, and we don't have to worry about incorrect scaling anymore. I will quickly add another object to the scene and do a quick render off screen so that we have something to work with when we get into importing our data to Fusion. So while I do that, you can take a little break, and I will see you in part 3 of this class.